So, thank you very much for attending, because I thought that I'll be the only person here, and I would go over to Kostis' talk. So, this talk is called "What can be done with Java, but should be better done with Erlang," and it's about my experiences. I've did a lot of work traveling from one Java user group to another in Germany, presenting Erlang to people, doing live hacking there, and well, collecting information, how I can describe what is the difference between those two, where could Erlang better fit in, and how it can help to solve different problems that are common in the Java world. And well, briefly about me, I'm Pavlo Baron. I'm working for Codecentric here, and it's a German consultancy. We are doing scalable solutions, big data, and whatever buzz you have. And so I have a weird hobby. I'm writing books, and yes. So I actually wrote this one, and it's a German Erlang OTP book. It's about 2 days, now 2 days in market. So just go get it. It's, well, 80% Erlang and the rest is German. Okay, so when you ask somebody what sort of application should be optimally implemented using his language, his preferred language or his preferred platform, so a .NET dude would say everything which is Windows actually best works with .NET. Python dude would say, well, everything which is kind of scientific must be done in Python. So well, yeah. So yes, everything that is cool must be done in Ruby. There is a bunch of people on the JVM doing marginal languages like Clojure and Groovy and Scala. Some of them real rock, but well, they fail the market yet, and they will say that they can do everything that Java can do as well, but in a much better way. I'm just kidding. So the Java dude would say, we can do everything. And that's the problem that I'm facing in projects. I'm doing consultancy for people who are only able to implement things in Java. And it's not always the optimal way they do it. It's all about enterprise Java, and enterprise Java is a world for itself. It's different from anything else. Okay, in Erlang, I would say that if you ask somebody, he would say, well, if it fits in, this will be done in Erlang. If it doesn't, well, I guess it will not. It shouldn't be, so go get yourself another language. Personally, me, I'm into this for now over 20 years in this business, and I become very picky on my way. I try to use Java after years of C++, C before that, and assembly and all that. So, well, I've seen some shit on my way. I did some shit on my way, and I'm still doing some shit on my way. So let's assume that I just need pictures. You need to talk in pictures. Let's assume that Java is a hammer, Erlang is a saw. Yeah. So let's start with one example. How would you implement a functional map? Well, a map function in Java. That's the way to do it. I mean, the target audience was, according to the program, was Java people. Is there anybody who's doing Java around? 1, 2, 3? Oh, cool. Well, everybody does Java somehow. Does anybody do enterprise Java? Okay. Does anybody actually like enterprise Java? Okay. Nice. So feel free to throw bottles on me. So yes, this is one way to implement map in Java. It's just, well, the other way you can do pseudo functional stuff with Guava, for example. And, well, just count the lines of code. It's very eloquent. It's not that expressive. So it becomes worse with filter and fold and all that stuff, you know, from functional languages. So in Erlang, you would do it like that. So everybody here is also doing Erlang, right? I don't need to dig into it because it's very difficult to do this stuff in front of people who have never seen Erlang, so the syntax must be explained and all that. Yeah, so that's the way. This is a one-liner. So a Java dude would say, so what? I mean, if it has to be a one-liner, it will be a one-liner. And, well, of course your colleagues will love it as soon as you commit it. And, well, the way you fight the eloquence of your language, of the Java language, in this enterprise Java world, you use an IDE with generators, accelerators, and all that. So you can say, so what? I mean, I click once and code just, you know, falls out of something. Yes, that works. But, I mean, you work around your language, you work around your platform. So the other thing is that the standard way to do parallelism on the Java platform with Java is to synchronize things. And, well, you have threads and you have synchronization on different levels and all that. And the Erlang concept is just, you know, single assignment with pattern matching here afterwards. So you know this syntax very, very well, so I can save time. And this just, you know, actually there are logs when you dig into the source code of the platform. Of course there are logs in different situations, but there are no explicit logs you would do. So when the Java guys, well, I tell this to the Java guy, he will say, so what? I mean, there is a bunch of tutorials on the web describing how to do this same thing in Java. Like, you know, the simplest ways to avoid problems with concurrencies. Actually, it's the text from a very popular tutorial on Java. To avoid problems with concurrencies, to share only immutable data between threads. And so on and so forth. You can do this final and class declaring final and private stuff and all that. But yes, that works. But once again, that's not the standard way to do it. So I mean, you work around the platform once again. Is it readable for everybody? Okay, so it's not necessary to dig into details. I just can explain it. You have you do endless recursion here on the Java platform, just endlessly with Java. And there is no base case in this recursion, so you get a Stack Overflow exception error. That's because Java leaks, basically, TCO, TRO, and all that. It's not the way to implement, you know, iterations in Java using recursion, not the standard way. So well, I mean, when you do it in Erlang, some weird stuff which is completely unusable, but you just keep calling yourself, and hours later you will break it somehow, because, you know, yeah. I need to go on. I had to do my slides. So the Java dude would say, so what? Once again, this is a piece of code from Erlang. This is something that Carsten generates there. I've used to contribute some things to this platform, to this experiment. And well, the way you do it, you just replace recursion with a loop, you know, and you have on the stack, you have only one reference to the object outside. The object is somewhere in the heap, and you can override those attributes there as well. So that's the way to do it. Of course, that works. And I mean, that's a hack. That's a tweak. This is not standard, but it's a standard way to do it on the Java platform. So the other thing is, for example, you have, well, it's a strongly typed language, of course, and you have do it with an integer, do it with a string, and I just, you know, print what it is. And in Erlang, you would do it using pattern matching on functions. So that's the way to differentiate between different incarnations of functions, different bodies and all that. So I don't need to explain this code. And once again, the Java dude would say, so what? I mean, what I can do is I write a generic doIt method taking an object and having a lot of if and else statements there where I try to find out what it is and you know, print it out. So I can simulate sort of pattern matching here. But of course, we all know you can do much more with this pattern matching. The reason is that you can pattern match even ranges and values and all that. So that's the way, the best way to you know, to define a contract of a function. So the contract in Java would look like if, else, if, and not all that. It's, for me personally, it's not that well readable. So the next thing is, well, reloading classes. The standard way in Java to reload classes is, well, you have a class loader hierarchy, and you know, you need a class loader, another class loader to reload your classes and all that. And when you do so, have a bunch of checked exceptions that are a pretty nice thing in Java, which is very popular. I'm sarcastic. So you have to check this all somehow. And the problem with this approach is that excessive class reloading using those class loaders is expensive. And it leads to so-called instance fatigue. It's something like, I mean, you reload classes 10 times in production, and then your JBoss starts, I mean, did you ever try it? So, yeah, it doesn't work then anymore. So that's the problem. Whatever happens, that's why it's strongly recommended to do hot deployment in production on application servers in the Java world. Not. And I mean, in Erlang you have, well, you might say it's not perfect, but it does a job very well. You have this hot swap thing, you know, it's just, it has its rules and however you call these functions and all that. And it's just necessary to recompile the thing and you get it and you get the new version there. It's not simple. I don't say it's simple, but it's been designed to, you know, to run somewhere under the earth for years and not being touched directly somehow. So you can push code in there and reload it and it still works. And you even can do in the OTP world, you can even react on changes, because the biggest problem with redeployment, with hot deployment of things is the state. That's the biggest problem. You have state that's somehow here, for example, a user session or something, and whenever you put a new code in there, this code might modify the structure of your state, and you need to deal with this situation somehow. So in Erlang, you would do a migration of the state if you can, and try to save this data for, you know, after the reload. So the Java dude would say, so what again? I mean, okay, I can use JVM hot swap or things like OSGI. So did anybody use OSGI? Okay. Are you happy with OSGI? No. Okay, great. I have not to expect bottles, I hope so, flying into my face. This is my normal problem. That's my typical fear, you know. The JVM hot swap is limited to method bodies. You cannot implement new methods. You cannot bring them in, and you cannot modify your classes and fields and all that. You just have to reload this one thing. The OSGI itself is invasive. You need to modify your application. You need to do lots of dependency stuff, and that really sucks for me. I'm sorry. And it's absolutely state unaware. So you just reload, and well, it does nothing with the state. You have to deal with it, but you have no callbacks or something. So once again, my Java friend would say, so what? I have JRebel, LiveRebel is the other product. You know this stuff? So it's just for tweaking on the JVM in a running process, just tweaking something. So you can reload code actually, binary code in the memory. And, well, it works, but I mean, if you're a startup, I'm not working for startups, I mean, doing consultancy, that's the problem maybe. In a startup, you do it all on yourself. In a big company, you have ops, and you have management, and you have, well, they are getting paid for stability and all that, so the platforms have to run. Or you have, for example, a situation like, if it's not described in your job description that this tool is included there, the guy would say, hey, come on, I need 2 weeks training and a vacation after that somehow before I do it. So that's why your ops will love it as well. This thing, from my experience, is very difficult to bring to banks and all that. Of course, those things work, but again, once again, they work around problems. And compared to that, Erlang platform was designed to meet, to face this stuff somehow. So the other thing is when you just, I mean, in Java, I just divide by 0 here, and it crashes. But what is interesting about Java, it leaves you all alone with this situation. You have, well, you need to develop stuff on yourself to react on all that. And we all know that supervision in Erlang is a real great thing, that you can just react on processes crashing and bring them up. It's just an example here from the shell. And somehow magically, for people who don't know how it works, it's like, the state has been externalized and brought in again to the new reincarnation of this process. That's the way, that's the standard way here. So the Java dude would say again, so what? I can do this like that. I mean, I just prevent things from happening. I can catch everything. I can catch, for example, let's go with integers in there and check once again if those are real integers. Then check a special situation and that b is not 0. Then you do a huge try-catch combo here, and you're catching arithmetic exception, which will never happen because actually this has been pre-caught here. Then something like wrong stellar constellation exception, moving the stars away, and wrong sun position exception, where you move after the star, angle 45 degrees to horizon, something round for your life. And it's still not enough. You will find a catch exception there in any code base, even in mine. So it's just for the case that something goes wrong. And still it's not enough, because real weird thing can happen. So you have a catch throwable there. So whatever it is. I mean, yes, that works, but actually it's not possible to foresee every possible situation where it crashes. And so the principle here in the Erlang world is let it crash and then bring it up. Okay, so let's check out the size of objects. Did you ever actively measure the size of your object and all that? I mean, if you're loading a real huge graph into memory and you're realizing that, well, you did a sort of abstraction here with a mapping integer to string, and you have one single method here, and you do add just 3 objects there, you end up having 608 bytes of memory used for this thing, and it's nothing. It doesn't even have a value. So Erlang is close to the machine. It's close to C. And so, for example, it's just an example here with a bit size. If you say that my number must fit into 5 bits, so this will be 5 bits. Of course, this example is not that well because it will have to be aligned somehow to 8 internally. But if you imagine a huge amount of them, so it pays off. A Java dude would say, so what? I mean, I can do this. I just rewrite my code. I'm not having any maps anymore. I'm just having 2 parallel arrays. One are integers. The second one is a multidimensional byte array. where I just simulate mapping of integers to strings and all that. I don't even use strings, I use byte array and all that. So I reduce the amount of memory used for this thing to 192 byte. But still, it does nothing here. And of course this works, but I mean, just look at this code. It's supposed to be C with some garbage collection, actually. So it has nothing to do with object orientation anymore, object graphs and something. So the way you would implement message passing in Java, in a way, I mean, there are emerging ways to do so, but the standard way is JMS, of course. So it's a lot of code for nothing here, just sending a message and you know, waiting for one response. Of course, Erlang was built to have, well, natively integrated or provided message passing. We know this, and it's a great feature. It's the feature, well, I mean, this is the basic of everything we do. And, well, you can actually, theoretically, you can have plenty of parallel actors running in the operating system process. And, well, as soon as they start using memory, it will somehow be not that funny with this number. But, OK, you can have theoretically 2 to the 27 processes in parallel in one instance. So what would say the Java guy? I can use something like kill him. It's also something that Craftsman utilizes in his urging. So it's an actor library or actor framework for Java. And it's, well, for a geek, it's a pretty neat thing. Because, well, it does continuation passing style simulation. You know, you have to throw a possible exception, and it has a weaver which modifies your code before it gets loaded. Well, actually, when it's compiled, when it's getting compiled. And then still, you have that many lines of code just to bring up a mailbox and, you know, write stuff compared to the Erlang syntax, however weird it might be. I'm sarcastic again. Yeah, it's still much more, it's much more weird for me than the other way around. So your ops actually will love this too, because this is something that, well, it's not that well predictable for guys who are, well, who want to minimize the impact of tools being used there. Again, I'm working more in the sector where we are dealing with big customers and all that. Yes, that works actually, but it's a tweak. It's a nice tweak actually. The numbers are impressive, what they can do on the JVM. It's like not using threads. It's just, you know, just say freezing variables and reactivating them later. The way you would do distributed stuff, distributed message passing, is the same way. You would use something like JMS, and, well, we know that with a little modification here, you can do it in Erlang very comfortably. The Java guy would say, so what? Of course, I have grid gain, for example. The grid gain actually is also a nice thing for distribution and distribution of tasks and all that. You can do much more. You can even do map reduce if you like. And the problem with this approach is that, again, it's not predictable. It's not the typical situation that you want to have as a operations guy in a bank doing Java stuff. As few as possible libraries, as few as possible frameworks, and you know, you need to be able to run stuff from scratch, and those kinky things are not allowed. And garbage collection is the other example. Well, just to compare, you have garbage collection per operating system process in Java. Have, of course, a pretty complex generation management and different GC strategies, which are not known by everybody. And you have possibility for these stop-the-world situations. Compared to this, you have in Erlang, well, a straightforward garbage collector for processes with some exceptions and all that. And stop-the-world situations are unlikely. It's just to compare this. So what would say the Java guy? Just throw more memory on it. I mean, memory costs nothing, so let's throw memory on it. Of course I can, yeah. I can do this to a point before it starts hitting me back. And so what is the message? I mean, when I've been talking to Java guys, and they are asking me, so what do you mean, would you use Erlang for everything? I'm not, I told you I'm picky. Maybe I'm, well, too picky with that. I wouldn't actually use Erlang for everything. So, yeah, you can, of course, implement web applications, classic web applications with Erlang too. You can also do this with assembly. And you can also open bottles, wine bottles with shoes. This also works. Just check out the video on YouTube, how the dude does this. But, I mean, the Java guy with millions of different frameworks, I mean, everything, will just laugh about it. And, well, the guy who laughs much more about it is the Ruby on Rails guy, of course, because he says, hey, I'm inventing the web. Yeah, so the Erlang, well, the one other thing is business applications, classical business applications, where you might have a situation where, well, you have to deal with millions of different calendar formats somehow. So you would do something on yourself here, on your own in Erlang, because, well, it's for another purposes, this platform. It's not for typical business enterprise applications at all. So in this case, JavaDude will laugh about it. And for example, well, the third thing that comes into my mind is number crunching, because you do time sharing on the Erlang platform typically. You don't want long runs to block the schedule and all that. And the Java guy would say, hey, my platform is great for number crunching and all. But the C guy will say the same. And personally, I would prefer doing this stuff in C because of, I don't want another abstraction there. So that's it. Thank you very much. Questions?